Caring for muscles in older age. A scientific perspective. As individuals age, their bodies undergo a multitude of changes, many of which directly affect muscle health. One of the most significant changes is the progressive loss of muscle mass and strength, a condition known as sarcopenia. According to medical science, this process begins as early as the fourth decade of life and accelerates after the age of 60. For seniors, maintaining muscle health is not merely a matter of aesthetics or mobility. It is a critical determinant of independence, metabolic health, quality of life, and longevity. This essay explores the importance of muscle health in seniors, the physiological changes associated with aging, and science-backed strategies that older adults can adopt to care for their muscles effectively. The importance of muscle health in seniors. Muscles are essential not only for movement but also for many vital physiological functions. They contribute to metabolic regulation, glucose homeostasis, and thermoregulation. In seniors, muscle health is directly linked to the ability to perform activities of daily living, such as walking, climbing stairs, rising from a chair, and carrying groceries. Loss of muscle mass and strength is associated with increased risks of falls, fractures, hospitalizations, and mortality. Moreover, muscle tissue plays a key role in buffering blood glucose levels, which has implications for the management of type 2 diabetes, a condition prevalent among older adults. According to the National Institute on Aging, more than 1 in 3 adults over the age of 65 falls each year, and weakened muscles are a leading risk factor. Sarcopenia also contributes to frailty, which is associated with a 3-fold increase in the risk of death and institutionalization. Studies have shown that seniors with greater muscle strength perform better on cognitive tests, indicating a potential link between muscular and neurological health. Thus, preserving muscle health is not just about staying active, it's about protecting mental sharpness, reducing healthcare costs, maintaining autonomy, and prolonging life. Age-related changes in muscle physiology. Understanding the biological processes that affect muscles during aging is essential to combat their negative effects. Key changes include 1. Muscle fiber atrophy. Muscles are composed of 2 primary types of fibers, type 1 slow twitch and type 2 fast twitch. As we age, type 2 fibers, which generate rapid force, atrophy more than type 1 fibers. This leads to slower reaction times, reduced strength, and an increased risk of tripping and falling. 2. Reduction in satellite cells. Satellite cells are involved in muscle regeneration. With age, the number and functionality of these cells decline, impairing the muscle's ability to recover from injury or respond to exercise stimuli. 3. Neuromuscular dysfunction. Motor neurons degenerate over time, leading to denervation of muscle fibers. Some fibers may be reinnervated by neighboring neurons, but this compensatory mechanism becomes less effective with age, resulting in muscle atrophy and impaired coordination. 4. Hormonal declines. Decreases in anabolic hormones such as testosterone, estrogen, growth hormone, and insulin-like growth factor 1 (IGF-1) diminish the body's ability to synthesize new muscle proteins. 5. Chronic inflammation. Aging is associated with a low-grade inflammatory state. Elevated inflammatory markers such as interleukin-6, IL-6, and C-reactive protein, CRP, are linked to muscle protein breakdown and are associated with weaker physical performance. 6. Mitochondrial dysfunction. The energy-producing powerhouses of the cell decline in function with age, leading to less efficient energy production and more oxidative stress, which damages muscle tissue. Strategies for maintaining and building muscle in seniors. Scientific research has demonstrated that muscle loss is not inevitable. With proper care and intervention, older adults can preserve, and even increase, their muscle mass and strength. 1. Resistance training. Resistance training is the gold standard for muscle preservation. It directly stimulates muscle protein synthesis and enhances neuromuscular coordination. Evidence. A study published in the Journal of the American Geriatric Society found that older adults who engaged in a 12-week resistance training program experienced significant increases in muscle strength and size, regardless of starting age. Examples. Exercises such as squats, leg presses, dumbbell curls, and chest presses. Adaptations. For those with joint pain or limited mobility, chair-based resistance training or water-based resistance workouts can be excellent alternatives. Public health policy and personal wellness initiatives alike. Stay strong, live long, caring for muscles in your golden years.